Now I am presenting my final project here for the tall building. First we will go to file, then open a new model. We'll set these display units, steel section as Indian, design code as IS 800 2007 and concrete, and click OK. We are taking number of grid lines as 4, number of grid lines in y direction as 4, and spacing in x direction is 6 meter and y direction is also 6 meter. Number of stories we are taking as 23 and typical story data are 3 and 3 meter. Now we will do on the work on the basis of similar story project. So we'll go to story, custom story data, and we will click edit story data. Now in our project, story 1 to 8 are one type of similar story. So we'll select story 8 as a master story and other story as similar story to story number 8. Now similar, the second set of similar story are 9 to 14. So I will set the story number 14 as a master story and the story number 13 to 9 as similar to story number 14. The second set is 15 to 19. So I will set the story number 90 as a master story and the other story similar to story number 19. Okay. Now the third set is already defined, that is story number 20 to 23, where the master story is 23 and all the story number 22, 21 and 20 are similar to story number 23. We will cross check once again 23 for 23, 23, 19, 19, 19, 14, 14, 8. Now here there is a mistake. We will change this to story number 8. So every story 1 to 8 is 8. Now 14, 19 and 23. Click OK. We will use the grid only options and click OK. Now we'll define the material properties. We'll see here the grids and the 3D view of the grid shown in the 3D view. Now we'll define the material properties. Go to define and then material properties, add new material. We take region as India, material property as concrete, standard as Indian and grade as M40 concrete, and click OK. Then again click OK. We will have defined the material properties. One material property is M40. Again for the rebar we have to define the material properties, add new material. Now we'll change the material type to rebar and grade as HOSD 500 for the longitudinal bars and click OK. Again click OK. Add new properties. In the region we have India, material type as rebar, standard as Indian, but for shear reinforcement we will take a grade of mild 250 and click OK and click OK. Now we have defined all the three material properties and now click OK. Now we will define the section properties. We will go to define, then section properties, select frame section. We have to first define the column, rectangular column. We have three different columns. One column is 600 by 600, 500 by 550 by 550 and 500 by 500. So we'll add new property, select a concrete, we'll give a name of column 500 by 500 and material properties as M40, depth as 500, width also 500. Go to modify show rebar. This is a column. Longitudinal bars as HYSD 500, confinements bars as mild 250. Now the cover, clear cover is 40 mm. Set it as it is and click OK and click again OK. Now we have to define another column properties of 550 by 550. Go select this column 500 by 500 and we will click add copy of property. Now change the name from column 550 by 550 by 550. Material property is same, only change the depth as 550 and width also as 550. Modify show rebars, it is already set because we have done previously, and click OK and again. Now a column of 500 by 550 by 550 has been defined. Now we again go to this and give another column of 600 by 600. Material property is M40. Now we have to change the depth by 600 and width by 600. Now check this, these are already set. Click OK and click OK. Now the column has been, all the three columns has been defined. Now we will put these three columns into auto select list so that the software automatically select the section according to the stress coming in that member. So we'll add new property, go to special option. Here we will get an auto select list. Click on this and name is as auto select column. As a concrete, auto select design type is concrete. Choose these three and add to the auto select list and click OK and click OK. Now we will define the beam property. Go to define, section properties, frame section. Now we will go to add new property, set a concrete. Now we'll define a beam of 500 by 300, material as M40, depth 500 and width of 300. We go to modify show rebar. We'll select here design type as beam. Give a top rebar cover of 25 mm and bottom rebar cover of 25 mm and longitudinal bars as HYSD 500 and confinement bars of mile 250 and click OK. Now the beam property and rebar properties has been defined and click OK. Now a beam of 500 by 300 has been defined. Now we have to define two other beams of 550 by 350 and 600 by 400. So we will select this and go to add copy of property, change the name as beam 550 by 350, material M40. Now change the depth of 550 and width 350. Show rebars, it is already set. OK. Now the beam of 550 by 350 has also been defined. Now another beam of 600 by 400. Go to add copy of property. We will set it as beam 600 by 400. Change the depth to 600 and width to 400. This is already set. OK. 600 by 400. Now click OK. Now these three beams, beam 500 by 300, 550 by 350 and 600 by 400 has been defined. Now we will put these three beams into auto select list so that the softwares automatically select the sections which is very economical for that stress. And we will go to add new property, auto select list, and name it as auto select B. Auto select design type as a concrete, and take these 3 beams and add in the auto select list and click OK. Now these 2 auto select beam and auto select column has been defined. Now click OK. Now we'll define the slab property. Go to slab section, add new property. We have a slab of 150 mm, so name it as slab 150, material type as M40, and thickness as 150 mm. Now click OK. Now we have set all the section properties and defined all the materials. Now we only have to model this. Now we will choose a column, quick draw column, and select the property as auto select column and set the story as similar story and go to story number 1. We are in the story number 1. We have selected to draw a quick draw column, the property of auto select column, and we have set the similar stories. So we will draw by dragging and selecting all the intersections of the grid point. Now the column has been drawn. You can see this in the 3D view. Now we have to draw a beam, quick draw beam. We'll select a quick draw beam and property is auto select beam. A similar story is already there. Now we'll drag and select all the grid points to define the beam sections. Now the beam has been drawn. Now we have to draw a slab. We'll take quick draw slab, floor option, floor or wall option, and we will select the property as 150 and drag and select all. The floor has been drawn in story number 1 to story number 8. Now we will, in this story number 1 to 8, we have drawn the columns, the beam and the slab. Now we will go to another set of similar story, that is story number 9 to 14. Now we are in the story number 9. We have to draw the columns, beams and slabs. In this set of similar stories, here see that the similar story has be there. Now we will take a quick draw column and place these column on the desired positions. The column has been placed at their desired positions. Now we'll take a beam and draw beam. Beam has also been drawn. Now we'll take a slab. One thing, always take care that when you are selecting the beam or column, also see the properties. Here see this slab 150. When I take a column, it was auto select column. When I take a beam, it was auto select beam. So take care of the properties that you are drawing. Now we will go to story number 15. Auto select column is there. We'll draw the column, add the desired positions. Then we'll draw a beam, then a slab, go to another set, in story number 20, quick draw column, then beam, and then slab. We have modeled this structure, all the columns, all the beams, and all the slabs. Now we have to apply loads on the structure. Now we will go to story number 1. We have to apply a dead load of 2 kilonewton. That will be same for each story. So we will select here as all stories, then select all stories is set. Now we will select all the shells. Automatically it will select all the cells in every story, but if there is no cells in the uppermost story, it will not select it. Now you can see that 140 shells are selected. Now we will assign a dead load. Go to assign, shell load, uniform, take dead load and give a value of 2 kilonewton per meter square and apply and click OK. Now the dead load has been assigned. You can see in every story. Now we have to apply live loads at different set of stories. So we will use here the similar story option to assign the live load. Here we will go to similar story. Now select these cells. Now we see, cross check it, 72 cells, 9 cells in one, and they are 1 to 8 story, therefore 8 9 is 72, therefore 72 cells has been selected. Now we have to assign a live load of 5 kilonewton per meter square and then apply and then click OK. A live load of 5 kilonewton per meter square has been assigned in story number 1 to story number 8. Now we will go to story number 9. Here in the story number 9 we have to assign a live load of 4.5 kilonewton. Now cross check it as the similar story has been checked. Now select these cells. 36 cells has been selected. Because there are 4 and 3 7 cells and the story number of story is 6, to 7 6 are 42. 42 cells has been selected. Now we have to assign frame load distributed, sorry, not a frame load, it is shell load, uniform, and live load as 4.5 kilonewton per meter square, then apply, then click OK. Now we will go to story number 15. The similar story has been there. Now we'll select the shells 25 cells has been selected. Go to assign shell load uniform live load of 4 kilonewton per meter square. Apply and click OK. Now we will go to story number 20. Now select the cells, assign shell load uniform. Here the load is 3.5 kilonewton per meter square. Click apply and then OK. Now we have applied the dead load of 2 kilonewton per meter square in every floor, and the live load also to every floors, but the live load was not same for each floor. For the group of 1 to 8 it was 5 kilonewton per meter square. For the group of floors 9 to 14 it was 4.5 kilonewton per meter square, and for 15 to 19 it was 4 kilonewton per meter square, and that of story number 20 to 23 was 3.5 kilonewton per meter square. You can see here at 3.5 is written, means 3.5 here. The frame load live load has been assigned of 3.5. Here at story number 2 we have a 5 kilonewton per meter square of live load. Now the dead load and live load has been assigned. Now we will assign the cladding loads of 0.2 kilonewton per meter square, and this will be a type of frame load. Again we will do with a similar stories because the shape is not same throughout this building, so we'll similar story and select these beams where we have to apply the cladding loads. Eight. Now we have selected the beams. Now we will assign the cladding load. Go to assign frame load distributed of 0.2 kilonewton per meter square. Apply and OK. Now again go to story number 9 and click OK. Select these beams. Sorry, there is no similar. Go click here. Now we'll get this similar story. Now select the beams. Select all the beams have been selected. Now go to assign frame load distributed of 0.2. Apply and OK. Now go to story number 15. OK. Here the similar story. Now select all the exterior beams. Now the exterior beams has been selected. Go to assign, go to frame load, then distributed, then apply, then OK. Now we will go to story number 20. Okay, now select. See here the 24 frames are selected according to similar story. Assign, go to frame load, distributed, and click apply and click OK. But in the story number 23 we do not need this load because there is no walls here. The story number 23, so we'll go to 23. Now set this as one story and select these beams. You can say 6 frames are selected. Go to assign, frame load, distributed, and then delete the existing loads. Then apply, then click OK. Now we will go to story number base story. We'll select the joints, go to assign joints, use train, and we'll select fix joint, then apply, then click OK. Now we have defined the joint. Now we will go to draw, auto draw clothing by floors, click OK. Now the auto draw, according to auto draw clothing, all the cladding has been drawn. Now we have to apply the wind loads. Now we will define the wind load. So go to define load pattern. Here in the load gives right wind and type as wind. We'll select the IS code of IS 1875 1987, then add new load, select this, modify lateral loads. Here the wind speed we are designing it for the Bangalore, so the wind speed is 33 meter per second. We can see all these values from IS 875, and terrain category as 3 for this building, structure class as C because the height of the building is above 50 meter, risk coefficient factor is 1 because the life of the building is greater than 50 years. And now for Bangalore, the upward wind slope is less than 3 degree, for which the topography factor is 1. We can see all these value from the IS 875 and according to our problems. So according to my this final project, the wind speed is 33 meter per second, the terrain category is 3, class as C, risk coefficient as 1, and topography as 1, and then click OK. Now we have defined the matter, and then now click OK. Now on the basis of height by width ratio and length by width ratio, we will find the wind pressure coefficients from the IS 875 1987. Now in this problem, the wind pressure coefficient for this problem I have calculated as plus 0.8, minus 0.25, minus 0.8, and minus 0.8 from the 4 sides, different sides of the building. So now we have to apply these wind pressure coefficient to the buildings. So we'll go to elevation view and then section A, then click OK. Now in section A, these are the cladding shown here. Now we will select all stories and click OK. Now select the shells. Now here we have selected this, and this, but some part of section B is also been there. So we will go to elevation B and select all these also. Now we have selected 65 cells. Now we go to assign, then go to shell loads, wind pressure coefficient of plus 0.8, and then apply, and then click OK. Now the wind pressure coefficient in elevation A and B has been assigned. Now we have to assign them. Now we can see in the story 1 here the wind pressure coefficient in this direction has been assigned. Now we have to define in this direction, that is in section C and section D. So we will go to elevation, section D, apply, OK. Now we will select these in section C. Now go to section C and select these cells. Now we have selected. Now go to assign shell load, wind pressure coefficient of minus 0.25 and leeward side, and then apply and click OK. Now we'll go to plan view and see this story 1. Wind has been applied. Now go to elevation view and section 1, click OK. Select all these cells because we have the pressure coefficient of equal minus 0.8, so we will select all the cells in every section. We will go to, this is the elevation view 1, go to elevation view 2, then 3, and then 4. And assign, go to shell load, wind pressure coefficient of minus 0.8, then apply, click OK. Go to plan view, go to story number 1 and check. See, these wind loads have been assigned. We have to see this also in story number 9 because the shape is different for story number 9. Now you can see the wind loads, how the wind loads are acting. You can see in story number also 15. Here you can see wind loads. As we have applied all the dead load, live load and wind load, now we have to analyze this structure. So we will go to analyze and run analysis. It will tell to save this project, so I will save this as a name of final project. And save this. Now the software will run analysis and you can check the status here. It will take time because this number of stories are high. Now the analysis has been complete. The maximum displacement and the minimum displacement at different positions has been given here. The maximum is 0.873 and that of minimum of minus 17.178 has been given, and this is the our model. Displacement view is shown in 3D view. The analysis has been completed. Now we will design this structure. Go to design, concrete revise preference. Now check the design code IS456. Now everything is done, is okay. Now click OK. Now go to design, concrete. Now we can select the design combination. So for the design combinations we have to define these design combinations too. So go to define, load combinations, add default load combination, concrete frame design, and click OK. Now the sixth design combination has been shown here. The first one is 1.5 dead load. The second one you can see on the arrow, it is coming 1.5 dead load plus 1.5 live load. The third one is 1.2 dead, 1.2 live, and 1.2 winds, and these are different 8 types of different load combinations. Now click OK. We have a load combinations. Go to design, concrete frame design, select design groups, design, concrete frame design, design combinations, all are in this. Now click OK. Now we have to only design, start design, and check. Here you can see that the analysis of the design sections differ. For 175 concrete frame, do you want to reiterate? Then click OK. It will again remove that section which are failing and apply the higher sections, and again it will analyze and design the structure automatically. Now the analysis and design section differ for 10 concrete frames. Do you want to reiterate? Once again I will do it. Now I will go to design and check, verify all members passed. See all the concrete frame passed the design check. Then click OK. So in this way we have designed the structure. Now we can take a report, a project report. Since the detailing option is not in there in this evaluation version, so we can do the detailing in CSI Detail is another software where in which you can detail now all the different project report you can see here. So in this way I have completed this project.